packet pushers.
Welcome to the IPv6 Buzz, where we dare to dive into the 128-bit address space wormhole. I'm Ed Horley.
And I'm Scott Hoag. On the show, we discuss all things IPv6, strategy, design, deployment, and operations.
And I'm Tom Coffeen. We've spent 20 plus years working with the IPv6 protocol. We run a consulting firm where we get IPv6 working for our customers.
And we're here to share some lessons learned and how to avoid common mistakes. We're glad you joined us. Today, we want to review some of the option differences between DHCP and DHCPv6. I think it might surprise listeners that they aren't the same, and you have to know the difference in order to be able to build out your DHCPv6 configuration properly. So maybe we jump in and talk a little bit about this, you guys, because I think this will catch, as I mentioned, a lot of people by surprise. And we've talked a lot about DHCPv6 on the podcast overall. We got a ton of shows that just sort of talk about it in general and more specifics. So we'll list out a bunch of the shows in the show notes so that you can sort of check those out. So I don't want to try and repeat ourselves too much, but we do want to jump into the particulars about what goes on around sort of this operational model and the configuration of, or the operating of, DHCPv6. I don't know, is there something that stands out to you guys in terms of something that's really important in terms of preference for operational model around v4 versus v6 here and DHCP and how to think about it?
Yeah, I mean, we've talked about DHCPv6 a lot, and how router advertisements are used to indicate to hosts that they would either do Slack or DHCPv6, where with IPv4 networks, it's just a UDP broadcast on the network that host wants to obtain an address. And that's a fundamental difference. We've had numerous shows talking about the differences between RAs and Slack and RDNSS and DHCPv6. And we did a show recently, show 155, where we talked about the differences between the protocol multicast versus UDP and different port numbers. We talked about all those different fundamental differences between the two protocols, but they're fairly similar. And if you want to have the same model for building out your v6 network as you do for your v4 network, you could use both.
Right. And DHCP feels the same as DHCPv6 for the mass majority of operations, right? Mm-hmm. It really doesn't feel that different. So maybe we can jump in and sort of talk about, hey, you're getting ready to deploy v6, you're getting ready to deploy DHCPv6 because you planned for it, you architected it. What do we do to get this stuff working? And what does that look like? And then basically, what are the gotchas that are probably going to happen to us along the way?
Yeah, DHCPv6 is similar to DHCP in that you have a client that's requesting an address. You have a relay, probably the first hop router, and then you have a DHCP or DHCPv6 server. And the same server you run DHCP on today likely has DHCPv6 as a function built into it. And so you just need to configure the relay, configure the server, plug in your host. I'm trivializing it.
Yeah. Devil's in the details.
But yeah, it's pretty easy to get it going and get that basic functionality of assigning an address to a host. That's really pretty easy. And in just a few minutes, you could have that working, provided you had IPv6 connectivity from that first hop router to the DHCPv6 server.
Right.
You would put a v6 address on your DHCPv6 server, and your client was going to hear a router advertisement when it connected to that network, and that router was configured to set the managed flag to 1,
right,
and the A flag off. Well, really just the managed config flag needs to be set on so that the client knows it needs to do stateful DHCPv6 address attainment.
A little gotcha there, though, related to Microsoft clients, right? They'll actually request a DHCPv6 address without the flag set to 1.
Yes.
That's true, yeah. Linux machines will wait to hear the RA with the M flag equal to 1 before they send out their solicit message. But a Windows host, if it doesn't hear an RA at all, it'll go ahead and try to do a solicit.
Yeah, and that can be a little shocking. It's like, well, I didn't actually configure this, but there it is, and I'm good to go.
Yeah, there's been documented troubleshooting issues where the router was configured to do the forwarding isn't set with an RA. Client gets an address, but doesn't have a default gateway, has IPv6 brokenness, because DHCP tried before the RA was working right.
And happy eyeballs saves you.
You never notice.
Well, and I do want to bring a fine point to what Scott brought up earlier, which is you may get that base functionality working of getting an address, but that may not mean that you have one-to-one correspondence between the functional attributes of what you set up in your DHCP scope, right, versus your DHCP v6 scope, right? You may have differences in terms of what is turned on by default and what's available by default in terms of preferences. And if you don't know to set all those parameters, while you may be handing out v6 addresses and things may be working over v6, you may not be getting all the functionality that you anticipated or was designed originally in your v4 network that didn't make it over to your v6 network. Is that a fair statement?
Yeah. Handing out the addresses is the easy part. It's then you realize, oh, well, my dual protocol client now has a v4 address and a v6 address that it obtained through DHCP and DHCPv6. But hang on a second, my DNS server is still just the v4 DNS server. Why did I not get a v6 DNS server? Oh, that's an option I have to set, and I didn't set it in the scope. I better go do that. And how do I do that? And you might have been used to setting DHCP option 6 in the past, and now you realize, oh, it's 23 in DHCPv6. Who makes up the numbers? Why are they different? Why are they not the same? Yeah.
That's a really good question.
They're messing with us. They're just messing with us, man.
Yeah. So that was, something I've struggled with over the years in learning about IPv6 is there wasn't ever a master list that lined up which ones for DHCP and which option numbers were the equivalent for DHCPv6. It wasn't listed anywhere I could find. So I started to make my own list, and that kept growing and growing. I was like, okay, well, we better write this down because other people probably run into the same issues.
I'm always amazed whenever I go look at the list, because you can look at like what's available in terms of DHCP available configuration parameters. IANA has a published site that you can go look this stuff up, and it gives you all the values. And I'm always amazed about how many things are in there that I'm just like, I never even thought of or never even used that, but I'm sure, someone's using it, but it's sort of like, okay, I totally forgot about that. It wasn't something that I ever thought you would configure in DNS, but there's a lot of stuff in there. A lot of different options. I'm used to the common ones like an NTP server and SIP services and TFTP and things of that nature, but there's a lot of things that are made available. Even things like, option 4RD and map rules and like just weird things. You're like, where did that come from? But clearly they're written in standards, so that's the reason they're all here. But it's still sort of interesting to see the list overall.
Yeah, where I started to run into problems and started to dig into DHCPv6 options is when my dynamic DNS wasn't working. Well, how do I share the fully qualified domain name or have the client indicate its host name so then it fills out the dynamic DNS correct? Well, what option does that? Oh, it's been option 81 in DHCP. Oh, now it's option 39 in DHCPv6. I was like, oh, that's weird. Okay. The other one we've mentioned is the default gateway. For DHCP, it's option 33, or then it became 121. There's the v4 default gateway within the scope. And then you start to look for the equivalent option in DHCPv6, and there isn't one.
The mystery abounds. Yeah, there's a lot of strangeness because even things like DNS not lining up, right? I guess the intent there was to try and maybe align port services to option numbers in some way, or I don't know what all the thought process was for all of these, right?
Yeah, they're really different because the domain name in DHCP is DHCP option 15, but then in DHCPv6, the domain suffix search order list is 24 in DHCPv6. I'm like, it doesn't make any sense how these are mapped. They're just random.
Maybe someone who's better qualified than ourselves knows the reason why for all the remapping and what happened there.
I think it's first come, first serve. Who asks IANA next gets the next one on the list, and they're sequential.
For the RFC, I think there's some truth to that because there's things like, the IAPD and IA prefix options are 25 and 26 respectively, right? So maybe it was just the order of like, when the RFC got pushed through and their request or their hold request to IANA in order to get that particular one. And that's it. And it's not any more complex or complicated than that. Although I noticed that 10 is unassigned. Were we like scared about 10 having some secret meeting?
I'd be scared of 13 or.
Yeah, 10 didn't make a lot of sense to me, but it's just not defined. This is our chance, you guys. We can just write an RFC that just defines what 10 is.
It's a base 10 phobia. I'm going to blame it on that.
That would be option A.
Yeah, it's sort of interesting how all of this lays out because it's definitely a bit of a surprise. So just realize if you're going through operationally and you're trying to match up everything, number one, you're not going to get a one-for-one match, right? Just because there's no default gateway in V6 in the current operational setups that V6 is built around. The router advertisement takes care of that particular process. So you don't need something in the DHCP server to define what that is versus you'll still have that in DHCP. There's going to be other ones that are going to be probably DHCP V6 only in some basis and not exist in DHCP at all.
Yeah. Like prefix delegation.
Yep. That doesn't make any sense in V4. Right. Yeah. That's totally true.
Mm-hmm. Yeah, it gets more complicated than that. Like for vendor-specific options, maybe in the past you've used 60 or 43 or 124 or 125. But now in DHCPv6, it's only 16 and 17. So you're like, well, which one matches exactly what I want to do? Or in the past with DHCP, you had a SIP server. It was 120. Pretty simple. But now in DHCPv6, there's 3 options for communicating a voice call control system or a SIP gateway, 21, 22, and 58. You're like, which one do I use? Even though you might learn the number, it's not exactly, and you may have to do a bit of testing as you line this up and prepare for your V6 rollout.
And you hope that the vendor documentation is accurate and they're telling you to do the right things, right?
Yeah.
That's the other part of it, because you'd be amazed how many times they're just like, oh, well, this is where it's supposed to fit. Clearly, that's what the developers intended. They never moved the port, right? Or listen on that option code, and suddenly you're like, oh, it doesn't really work. And you're like, did you actually test this in the lab? Find out they didn't. So there's a chance that, even though it's documented, it may not exactly be right. So test in a proof of concept. Don't roll this out on production until you're tested and validated that it works.
Yeah, that's for sure. Like if you're doing a wireless LAN deployment,
yep,
you're probably used to using 138 as the DHCP option to indicate the controller for the access point. But now that option is 52 for DHCPv6. So you have to make sure the option's different, set it, test it, plug in an access point.
And put the right value in, because that's only going to take a V6 value, right, for that cap-wap value. So
yeah, exactly.
Yeah, so there's interesting things like that where you can't just cut and copy over and expect everything to work. So
yeah, so when you're doing proof of concept testing, this is another thing to add to your list for your lab, is to have a good functional DHCPv6 server. And most DHCPv6 servers may not come with all the DHCPv6 options pre-built in. You may be creating custom options or defining these yourself, making sure the options are set up and the value is correct. Oh, should I have used a certain size of integer or a certain value, or was it a string? When you create the custom option, you need to make sure the data type is correct.
Right.
So it gets conveyed correctly to the client.
Is there now a list that consolidates?
There's an article I wrote that has a lot of them, but is not exhaustive.
Yeah, we'll link to that in the show notes. You're kind enough to put that together and push that up on the InfoBlocks IPv6 Center of Excellence, right? Talking both about some of the commonalities and differences. There's one blog article about that, and then the option differences, which is what we're talking about here in terms of covering some of that. So if you're scratching your head and you're trying to figure some of that out, I really suggest going and reading the article, because it'll make your life easier in the long run in terms of at least doing a bunch of the base fundamentals that you're probably doing today in DHCP, just being able to get those up and running in DHCPv6 so you're not messing those up.
And I guess put in the comments of the blog if you have new ones or new mappings or ones that you've learned about that, oh, if you're setting this in DHCP, you got to set this option in DHCPv6.
We've devoted an entire episode to one DHCP option.
Yeah.
Yeah.
Tom and I recorded show 110 where we talked about DHCP option 108 as a method of disabling IPv4.
Shh, don't mention that to other people. I guess my other question then is, we're talking about DHCPv6, we're talking about all this option parameter information that is associated with it. What if we're not doing DHCPv6? What if we're a Slack shop? Is there other things we need to take into consideration? Or maybe we're doing a combination of Slack and DHCPv6. Anything that we need to think about operationally there that would be important to sort of consider or have on our checklist?
Yeah, because the router advertisement can contain, DNS server information, DNS suffix search order list information. It does contain your default gateway, and there's a limited amount of, flags and things like that. And so they've expanded flags, and the IETF is constantly kind of expanding flag advertisement options, RFC 5175, having other kinds of flags set and other kinds of information in the router advertisement. There isn't as much functionality in RAs as exists with DHCP v6. You certainly have the ability to create a broad number of DHCP v6 options and data that are shared. And you can do that quicker than probably your router can get updated to include a new RA flag.
Yeah, are we headed in the direction where we're just basically going to have every DHCP v6 option we have, there'll be an equivalent within RAs?
Yeah, I guess I would preface that with a DHCPv6 IANA, right, as opposed to PD.
Yeah, exactly.
Yeah, so that's a nuance for the audience around prefix delegation. You can do a DHCPv6 specific parameter option for prefix delegation. That's a slightly different process than just end client getting a particular address, which is where we're talking about all the options that are associated with it. And to Tom's point, it seems to be that we want to write more and more RFCs that introduce expanded capabilities of RAs to include more and more information just naturally on the wire versus providing that via DHCPv6. And we're not here to tell you one way or the other.
Yeah.
Which operational role is better or worse, or which one services the end use function better. And it may be applicable that both are super important. So if you're running OT or IoT network, having those Slack options may make a lot of sense and may be very, very functionally useful for you.
Yeah, that's right. Operator choice, essentially, all other things being equal, that which grants the most operator choice, is probably the correct answer. Yeah.
Yeah, I guess you'd have two choices. You'd use RAs solely, or DHCPv6 implies that a router advertisement was sent before. So you can't do DHCPv6 without router advertisements. Realistically, you tend to go together.
It's just that prefix option of an A flag, right? That says like, hey, provision yourself one in some state. And I guess that's one thing that's sort of unique about the router advertisement too for Slack is that you can introduce multi-prefix option sets. I don't know, can you do that with DHCPv6? I guess if you have a different DUID, IAD, you could ask for multiple prefixes in theory. I don't know if that's really in practice. That would be something that you could do, but because I don't think I've ever seen that. It's just the prefix that that particular interface actually belongs to, right?
You're talking about an RA with two prefixes in it?
Yeah, versus DHCP being able to assign multiple prefixes down, which is just going to be a PD function, not an actual, multi-prefix on the interface function, which introduces a whole set of routing problems, right? DHCPv6 PD, because you have to route that particular block to that address. So there's scaling issues. We're getting into operations now, but there are things you have to think about in terms of impact.
Yeah, with an RA option, the IETF will have to invent the RA option, define it as an RFC,
right.
And then it needs to be implemented in your router software, and then it needs to be implemented in your host OS.
Right.
And that could take a bunch of years. We've talked about, how long it might take if you were to invent your own extension header. How long would it take before it actually was functional?
Right.
With DHCP v6, you could create an option in the host and on the server. The network equipment infrastructure does not need to be aware of that option. And the software and the routers don't need to know.
Although Scott, correct me if I'm wrong, there is firewall capabilities to filter DHCP scope options, right? Certain ones that you don't want to permit on a given network, you can filter them out. I think that might be something that could impair DHCP in terms of expanding a lot of option scope numbers in the future if they aren't defined by the RFC and you're just building your own on the fly because you wrote an application that makes use of it or something of that nature. I guess you would have to be cognizant of the fact that you may operationally may not have full control over all the DHCPv6 options that make it through on the network itself, right?
There is space to create your own if you wanted to custom create your own option numbers.
It's 151 to 65,535 is unassigned, right? But I don't know. I think there's a defined space that's just out of that's defined as being something that you can use. But
I'd forgotten that it's 65K at 16 bits of option space. For whatever reason, I thought it was just 8. That's huge. Yeah.
Yeah, it's huge.
Yeah, a ton of options. Where at DHCP, it's an 8-bit option code.
Yeah, that's what I was thinking. Yeah.
Yeah.
So that's another difference in terms of the operational aspect. Well, very cool. I think we sort of covered, hey, be aware, look out. This might be something that might operationally at least take you by surprise. And it may take a little bit of time and effort and a little bit of homework to figure it out. The good news is once you do it once, you can go through and probably pick it up and and copy it scope to scope pretty easily and change the small things that need to change from one scope to the other. And hopefully you're using some sort of DDI tool and it's making your life a little bit easier for these things in terms of configuration and operation and maintenance versus going in and doing this by hand every single time. So that's our little bit of advice. Use a tool. Some of these are pre-built in, although with V6, I've noticed you don't get anywhere near as many pre-built options as what you probably see with IPv4. I don't know if that's a fair statement, but that's been my observation, at least to date, for a bunch of products.
It depends. If you're a salaried employee, then automate. If you're hourly employee, then don't automate and do it manually.
Curate those by hand.
Yeah.
Well, is there anything else we wanted to close out with? We've talked sort of through the RA versus the DHCPv6, sort of the A flag, M flag, and option scope info. I guess I would have one final thing to mention, which is, and this is probably more of a host OS thing than it is necessarily a DHCPv6 option thing, but do realize that host OSs behave differently if they get both DHCPv6 information and Slack related information with the options. And every operating system is going to do something slightly different in terms of their preference or for accepting them, how they fail back from one to the other. So your mileage will vary on those. I don't know if Scott or Tom, you wanted to talk about that at all, but it is something to just be aware of.
And also, if you're experimenting with DHCPv6 and you've got a question about option numbers or you run into a problem, let us know. You can give us a feedback on the Packet Pushers podcast. You can do a follow-up or an FU, as they call it, using their form, and you can let us know if you've run into problems or if you've got something interesting mapping, or you come across a list that has all these that we didn't know about.
Let us know about that. And you can also hit us up in the Slack channel. We have the community Slack channel too, which is really good. And there's actually an IPv6 Buzz channel in there. So feel free to hit us up and chat with us. I'd be more than happy to sort of hear what you guys are running into. Thanks for joining us for this episode of IPv6 Buzz. If you've got feedback or a follow-up on this topic, send us a message at packetpushers.net/FU. We'd love to hear from you and continue the conversation.
Also, on packetpushers.net, you'll find a range of deep dive technical podcasts for IT pros, including heavy networking, heavy wireless, and Day 2 cloud.
There's a whole lot more on the Packet Pushers site as well, such as tutorial videos and a networking job board to help you find or fill your next great role. So whether you're deep in your career or just starting up, Packet Pushers is the place to go to grow both your skills and your personal network.
So long and until next time, we'll see you on the IPv6 internet.